Hi guys, in this video we will learn that how we can add a simulation model to an op-amp or to any of the components that do not have its simulation model already present in the KiCad. In the previous video we have seen that we have used this op-amp from the PSpice library. But now we are going to use an op-amp that do not have the simulation model already present in this KiCad. So for doing that, let's go to add symbol, and I am going to choose OPA 1641 for my current simulation. As you can see that it's just only the symbol we have in the KiCad. So let's choose this and hit OK and place on the canvas, and let's remove this previously used op-amp and select and hit delete, and let's place this OPA 1641 over here in your circuit. Now let's see what message will pop if you go to inspect and go to simulator. It's currently saying nothing. Let's say if we add simulation, and it says that error during netlist generation, no simulation model definition found for symbol U2. It means, let's cancel this and close this. It says that U2 do not have a simulation model. So before performing any analysis on this circuit, we will try to add simulation model of OPA 1641. So for doing that, you can go to Google and let's say it is from Texas Instrument OPA 1641, and let's search this, and over here go to its page. And as you must remember that KiCad and ngSpice do not provide the simulation models, as you can know that OPA 1641 is manufactured by the Texas Instrument, so they provide the simulation models for this op-amp. So the simulation models are in the design and development section. Over here you can see that OPA 164X PSpice model, and there are other simulation models over here, but we are going to use this PSpice model. So let's click on the download, and this will download, and go to the download section. In the downloads we have this zip file of that OPA 1641 simulation model. Right click on it and click extract here. So these are the files that were present in the simulation model zip file. So from there we have this one .lib extension file of the simulation model, and let's open in Notepad to see the file. And over here you can see that over here it starts from over here .subcircuit OPA 1641X. So this is our simulation file that we have just extracted from this zip file. You can place it anywhere where you have all your list of simulation models, so that you can remember the location of this file. So let's go to KiCad, and in order to add the simulation file to this OPA 1641 symbol, click on this and go to its properties. In the properties over here you see over here it says simulation model. Click on this, and now it asks for spice model from file.lib, and over here in the file click over here, go to download and choose that file OPA 164X, and hit open. The next thing is we have to choose the models which you are going to use for your simulation. So I am going to use this one, OPA164X, and hit OK. If you run the simulation at this moment, will the simulation run? No, because as you know that these pins 2, 3, 7, 6 and 4 are in accordance with the footprint of the this operational amplifier. Similarly, these pins should match with the simulation model file. So for doing that, again go to its properties, and in the properties go to simulation model, and you have another tab that is pin assignment. So over here you see that it has given the pin symbol pins and the model pins. So your symbol pins should match with the model pins. So to make a match between them, as you know that over here the symbol pin 1 is not connected, so click on this and choose not connected. Similarly, pin number 2 is negative input, so over here pin number 2 is negative. Pin number 3 is positive, but in model it is VCC. We have to change it to pin number 2 in plus as our model pin. And the next is symbol pin number 4 is minus negative voltage. We have over here VE, that is negative voltage. And pin number 5 is not connected in symbol, so in model we have to choose not connected. Pin number 6, as you can see over here, this is output, so we have to choose this as out. Pin number 7 is V plus, that is VCC, and pin number 8 is not connected, so we have not connected over here. In this way you can you make a resemblance between the symbol pins and the model pin. So over here we have pin number 1 of symbol not connected in model pin. Similarly, pin number 2 is a negative input, model pin is negative input. Pin number 3 is positive input, model pin positive input. Symbol pin negative minus voltage and model pin minus voltage. So in this way we have created a resemblance between the symbol pins and the model pins. And now hit OK. Let's save your work. Now the next thing is, let's say we want to change its gain, and by changing the gain, let's say this is 20 kilo, I change it to 100 kilo, and let's reduce the voltage of this input signal. Right click on this, go to properties, and in the properties go to over here, and let's say I want to give input of 0.1, and now hit OK. In this way the op-amp has an inverting amplifier with a gain of 10. Now in order to run the simulation, first of all let's save, go to inspect and start the simulator. The next thing is we want to create a new tab for simulation analysis and choose the transient analysis. Let's choose time step as 10 microsecond and final time as 10 millisecond, and let's hit OK. And we want to see our input voltage and output voltage relation with one another, so let's run the simulation. So over here you can see that we have input voltage in red and the output voltage in this blue color, and you can see that as the voltage is on the positive side, the output voltage is negative, and that is multiplied with the 10. As you can see over here it is maximum 0.1 and it is now -1. So in this way you can run your simulation. This we have done transient analysis. The next analysis we want to do is AC small signal analysis. For doing that, let's say I want to choose 10 points per decade and start frequency 10 Hz and stop frequency, let's say 10 mega, and let's hit OK. And I want to see V out gain and V out phase, and let's run the simulation. So over here you can see that we have a graph. On the y-axis there is a gain that is in dBs, and on the x-axis we have frequency, and we have choose the maximum frequency till 10 megahertz. So in this way you can add your simulation model by downloading from the manufacturer site and attaching it with the symbol in the KiCad schematic editor, and you can run your simulation. So hope you have understood how you can download and use simulation model in your circuit. In order to save your analysis you have performed in your circuit, like we have performed transient and AC analysis, you want to save this, go to file, save workbook as, and choose the location where you want to save. Let's say I want to save with the name OPA1641 and want to save on the desktop, and hit now save, and you have now saved your work. Let's see, we have this file that we have just saved our analysis over here.